Now children, that we are aware of the distance formula to calculate the distance between any 2 points. So let's look into the first problem. Find the distance between R and S. These are the 2 points with the given coordinates x1, y1, x2, y2. So the first one, to find the distance between R and S. The usual formula that we use is square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Let's jot down the coordinates of R, that is 0 minus 3, and S, that is 0, 5 upon 2. Looking into the problem, we can see that x1 and x2, coordinates x1 and x2, both are equal to 0. Coordinates y1 is given by minus 3 and coordinate y2 is 5 upon 2. Yes, definitely we can find the distance between RS by using the distance formula. Let's continue with it. So distance RS will be equal to square root of, let's substitute, x2 is 0, 0 minus x1, that is 0 minus 0 the whole square, plus y2, that is 5 upon 2, minus y1, that is minus 3. So let's not forget to insert the bracket, close the bracket, the whole square. As we continue, children, we know that we have to solve each bracket at a time. So 0 minus 0 has no value. That gives us 0 the whole square plus, let's look inside the bracket. We have 5 upon 2. Let's jot it down. Minus into minus gives me plus 3 the whole square. To continue with, distance RS will be equal to square root of 0 square is 0. So either you jot it down, pen it down, or you can keep it as it is, plus, now 5 upon 2 plus 3. We know, children, we have the LCM method to solve this term. 5 upon 2 plus 3. When there is no denominator, it is taken as 1. The LCM between 2 and 1 is 2. First numerator as it is, because the denominator is equivalent to the LCM, plus 1 into 2 will give me equal to the LCM denominator, that is 2. Whatever you do in the denominator should also be done in the numerator. 3 2s are 6. So 11 upon 2. So the answer for this bracket will be 11 upon 2 the whole square. Let me continue over here. So distance RS will be equal to square root of, as 0 has no value, need not write it back again. We are just left with 11 upon 2 the whole square. Square root of 11 upon 2 the whole square. So children, distance RS will be equal to square root of 11 upon 2 the whole square means 11 upon 2 into 11 upon 2. So you are just left with 11 upon 2 units. So this gives us the distance between RS. The answer is 11 upon 2. Now children, over here we used, I feel, a very long cut method where you use the distance formula, which is totally right. But if you observe the problem, here the coordinate of x for the points R and S is one and the same, 0. It can be minus 2, it can be 11, whatever. The coordinates of x coordinate, whether it is y or x, the coordinates are the same. So in this case, children, let's recall the other formula that we used to find the distance. Let's see by the other method, which is a shorter one. If we get the same answer, 11 upon 2 units. So what was that formula? We have seen in the first session. Distance between any 2 points is always greater coordinate minus smaller coordinate. So can we use it over here? Why? Because as we look into the problem, the coordinates of x are equal. So distance RS we can simply use as greater coordinate minus smaller coordinate. Over here, as x coordinates are same, let's not use them. So we just deal with the y coordinates. Which is greater? Is minus 3 greater or is y 5 upon 2 greater? So we see that all positive numbers are always greater than any negative value. So 5 upon 2 minus the smaller coordinate. The smaller coordinate also has the same negative sign. Insert it inside the bracket. So you have 5 upon 2 minus into minus again gives you plus. This, children, we have already solved in the earlier problem. 5 upon 2 plus 3 will give me 5 upon 2 plus 3 upon 1. Again, as we have already seen, 2 is the LCM. So 5 into 2 into 2, 3 2s are 6. So 5 plus 6 is equal to 11 upon 2 units. So the answer by using the distance formula, that is x2 minus x1 the whole square plus y2 minus y1 the whole square, the answer was 11 upon 2. But if we look into the problem more precisely before starting with it, whenever we have x coordinates or y coordinates the same, we can just utilize the other point, look into the greater coordinate and the smaller coordinate. So we get a smaller method to find out the distance which tallies with both the methods. So what did we use over here? y2 minus y1, that is greater coordinate minus smaller coordinate, which gave us the same answer, that is 11 upon 2. So over here, to calculate the distance between RS, we use the distance formula as well as the other method, that is greater minus smaller value of those 2 points. Let's look into the second problem now, children. Now, children, to decide whether the points are collinear or not. As we can see the problem over here, they have given 3 points P, Q and R to decide whether the points are collinear. To start off with the problem, let's first understand and brush up what are collinear points. A straight line passing through a number of points A, B, C, D, E will be called as collinear points. Points through which a straight line passes through are called as collinear points. Then what are non-collinear points? If I take a point F, then the set of points A, B, C, D, E and F together will be called as non-collinear points, as we cannot have a straight line passing through all the 6 points. So children, collinear points are points through which you can draw a straight line passing through all of them. Now, how do we decide if these 3 points are collinear? That means, is a line passing through point P, point Q, point R, irrespective of any point being between the other 2. For example, Q can be between P and R, or P can be between Q and R, or R can be between P and Q. So, how do we decide whether the points are collinear, whether a straight line passes through all the 3 points? For this, again, we will have to use the distance formula. We will have to calculate distance PQ, distance QR and distance PR. And the last part, if the greater answer, the distance between 2 points, is equal to the sum of the distances of the smaller two calculated, then we can say that the 3 points are collinear. So let's start to first find out distance PQ. So the first part, distance PQ, will be found out by using the distance formula, that is x2 minus x1 the whole square plus y2 minus y1 the whole square. For this, we will have to first assume what is x1 y1 and x2 y2. Looking at what we have to calculate is distance PQ. So the coordinates of P can be assigned as x1 y1 and coordinates of point Q can be assigned as x2 y2. So to begin, let's substitute. x2 is 1 minus x1 is minus 2. So the whole square, x2 minus x1 the whole square plus y2 that is 2 minus y1 that is 3 the whole square. So distance PQ will be equal to, let's first solve whatever is there in the first term inside the bracket. So 1 minus into minus gives us plus 2 the whole square plus, now inside the second bracket we have plus 2 minus 3 which gives us minus 1 the whole square. So distance PQ will be equal to 1 plus 2 gives us 3 the whole square. Now plus, let's solve this. Minus 1 into minus 1. Minus into minus is plus. And 1 square, that is 1 into 1 is 1. So distance PQ will be equal to 3 square is 9. Plus into plus again gives me plus with 1. So finally, therefore distance PQ is equal to square root of 10. We cannot further factorize. So the answer remains root of 10 units. So distance PQ is equal to root 10 units. So let's write it down, children. Distance PQ, we got it as root 10 units. To move on with, now let's calculate distance QR. The formula remains the same, that is the distance formula will be used again to calculate distance QR. So over here we have QR, distance QR. But now let's first assume what is x1 y1 and x2 y2. Looking into what we have to calculate, we have to consider only points Q and R. So Q, for point Q, our coordinates will be x1 y1 and R will be x2 y2. So let's calculate. Distance QR will be equal to x2, that is 4, minus 1 the whole square plus y2, that is 1, minus y1, that is 2 the whole square. Let's move to the next step for our calculations. Let's see what is inside the first bracket. 4 minus 1 gives us again 3 the whole square plus 1 minus 2 plus 1 minus 2 gives us minus 1 the whole square. So distance QR will be equal to, again 3 square gives us 9 plus minus 1 into minus 1, again minus into minus gives me plus 1 square, that is 1 into 1 gives me 1. 1 ones are 1. So distance QR is equal to 9 plus into plus is plus 1. So again distance QR is equal to root 10 units. So here again we got, children, distance QR with the same value, root 10 units. The distance between the points Q and R is equal to root 10 units. Now the third combination, that is distance PR. So again, using the same distance formula, let's calculate distance PR. Again over here, looking into the points, let's change the values of x1, y1 and x2, y2. As we have written PR, the coordinates of P we can assume as x1, y1 and R will be x2, y2. So to begin with, distance PR using the same distance formula, that is x2 minus x1 the whole square plus y2 minus y1 the whole square under root. So square root of x2 is 4 minus x1 is with a negative value. So let's put it inside the bracket. So x2 minus x1 the whole square plus y2, that is 1 minus 3 the whole square. So distance PR. The next step, as again we have already done the first term, let's calculate the answer. It will be 4. Now minus into minus gives me plus 2 the whole square plus, let's see inside the bracket what we have in store, 1 minus 3 plus 1 minus 3 gives me minus 2 the whole square. So distance PR. Let's see what we get. The answer in the first bracket, 4 plus 2 is 6 the whole square plus minus 2 into minus 2, it's a square, so minus 2 into minus 2, minus into minus is plus, 2 2s are 4. So distance PR will be equal to 6 6 are 36, plus into plus is a plus, 4 into 1, that is 4. When there is no number, it is taken as 1. So 1 into 4 gives me 4. So distance PR will be equal to 36 plus 4, that is 40. Is this the answer? No. We know that we factorize till the last step. That means split up 40 into its factors, which can be written as 4 into 10. And we know square root of 4 is 2. So distance PR will be equal to 2 root 10 units. 2 root 10 units. So the third distance, children, distance PR is equal to 2 root 10 units. Now, the last segment of the completion, towards the completion of the problem, is to decide whether the points are collinear or not. We have found out all the three distances between all the three combinations of taking point PQ first, then QR, and this distance PR. So now let's see what answers we have got after using the distance formula. The first one, distance PQ is equal to root 10 units. Distance QR is again the same answer, root 10 units, and distance PR is equal to root 10 units. Now we have seen, children, how do we decide if these 3 points are collinear? The answer, which is the largest number, gives us the largest number, that is 2 root 10 in this case. That should be equal to the sum of the other two smaller numbers when you add them up. So let's see. What is distance PQ plus distance QR? As the answers for these two are smaller than the third answer. So that is equal to, let's substitute root 10 plus root 10. So 1 root 10 plus 1 root 10. They are similar terms. So we can, like terms, so we can add them up. 1 root 10 plus 1 root 10 is 2 root 10 units. So we saw over here, children, when we add distance PQ plus distance QR together, the answer is equal to the third distance, that is distance PR, which is also equal to root 10. So how do we conclude? We say that as distance PQ plus distance QR is equal to distance PR. This left hand side answer is also 2 root 10 units. Here also distance PR is 2 root 10 units. So as distance PQ plus distance QR is equal to distance PR, therefore points P, Q and R are co-linear points. So here, children, we found out whenever they give you 3 numbers, how do we decide if those 3 points are collinear? If a straight line can pass through all the 3 points given. So for that, we just use the distance formula to calculate the distance between all the 3 combinations. And in the last segment of the problem we saw, if the sum of the distances of the smaller 2 answers is equal to the answer that we get, that is the largest answer, the distance between the 2 points, then we can conclude that the 3 points are co-linear points. So now, children, in addition, if at all we had to find out which point lies between the other 2. We have distance PQ, distance QR and distance PR. That means we have 3 points P, Q and R. Which point according to this equation would be lying in between the other 2? It is very simple, children. What did we get? We got distance PQ plus distance QR. So distance PQ plus distance QR was equal to distance PR. So naturally, which point lies between? Point Q lies between P and R. This is the symbolic notation of which point lies between the other 2. So looking into what we get, as distance PQ plus QR is equal to distance PR, that means point Q lies between P and R. So this is the way we find out whether the points are collinear or non-collinear. And with whatever we get as the conclusion, and if they are collinear points, definitely we can decide which point is lying between the other 2.